Awesome. Thanks, Jim. Thanks for having us. Super excited to talk to everybody today. And welcome to my co-presenter, Cody. Cody's going to kick off. I'll let you lead with your intro, Cody.
Awesome. Yeah. Hey, everybody. Thanks for coming to hear us talk. I run a company called Prescient. I'm the CTO and co-founder. We've developed some pretty cool forecasting models, particularly that do media mix modeling for our clients. We've got a really interesting business problem where we're running large amounts of forecasts at scale. And there are particularly these pretty whizzy Bayesian hierarchical forecasts, whole bunch of stuff going on under the hood. And one of the things that we needed to think about when we were first developing was how do you scale that, right? If you have multiple models using multiple different data sources per client, how do you actually scale that from one client up into 100 clients? And so you could be basically having thousands of models in production for different clients. And how do you actually maintain that, keep your features good and clean, and then how do you actually scale that across even a client, right? And so the way that we actually currently build models is if anybody's familiar with e-commerce, you could build a model for a particular SKU, but then you have to keep the data for that particular SKU and then potentially use that SKU's data for other hierarchical forecasts down the line. And so we wanted to make sure that we could scale our business, and one of the things that we didn't want to do from the get-go was build a feature store. I had done that already at a different company, and it's not easy, right? So what I was saying was, we have all these different models and productions, and one of the things that if anybody's familiar with Profit, for example, it's a pretty common algorithm by Facebook. One of the first things that's in the abstract of that research paper happens to be, hey, the people who build these forecasts are expensive, they're hard to come by. We needed to be able to have your average analyst be able to build a forecast and make some business insight with it. The thing about Facebook, they probably have all these KPIs that they're forecasting. We're similar in our, from the get-go, we wanted to make sure that our architecture was able to handle that kind of, scale, right? We didn't necessarily want to hire people like me because we're kind of useless. Researchers aren't that great. We cost a lot of money, and we kind of just sit around and talk about math. And so we didn't want to have to deal with that. So we wanted to hire people who are much smarter than myself to use the stuff that I write such that they can actually go do stuff with it and we can profit from it, right? And then who we sell our product to, this is a wonderful slide. We have all these different types of customers who have all these different types of data sources. And so we're using these features in a time series fashion and putting them into our models in order to gain some form of insight from it. But every single customer is different. And even internally within a customer, the way that we structure these forecasts could be different. So one of the things, again, like I said, we do hierarchical modeling. And so, for example, if we're doing SKUs and we want to use some, we do Bayesian, so if I say buzzwords, I apologize. If we want to use or make some inferences about some priors for particular SKUs, we can then use that information to inform our forecast for other SKUs if we don't have enough information for those, right? And so we have all this data that we really want to leverage, but we want to leverage it at different times during our pipelines and for different purposes. So it's just a really difficult business problem that we utilize Rasgo to help solve.
Awesome. So great overview from Cody. I'll go into a bit more on Rasgo as we go through some of the specific challenges and then the final architecture that Prescient landed on. So Cody, these are some of the challenges that kind of, if we synthesize, I think some of what you guys are experiencing as you look to start scaling Prescient, these are some of the things that jumped out. So can you speak to any of these that was like really a threat to Prescient as you look to build a business that you were really worried about solving for kind of before you took on the customer scale that you're looking to grow toward?
Yeah, of course. So I don't know what the population breakdown here is. I'm assuming that most folks here are engineers of some sort. And I'm not sure if those engineers have worked with marketers. Marketers typically don't like to wait for things. Which just makes me laugh because they really don't like to wait for things. And so one of the things that Prescient needed to focus on early on in this life cycle, we bring on a customer, we need action, we need to give them insights in order for them to make action as quickly as possible, right? And so if you think about that, even from the time that we start taking data from, some of these folks may not even have fully built data warehouses. So if we're pulling data out of Google Analytics or pulling data out of some other, Facebook, some ad platform, we would have to do that every single time for every single client and then format every single client's data by going into our own data warehouse where we have that data, write some SQL, pass that on to the models, so on and so forth, right? And so first bullet point that you see here, that was key for us, right? Because the longer it takes us to build a thing, the longer it takes for our clients to get that thing, and then the more mad they are, right? And marketers get mad. And if anybody's a marketer, I don't mean that meanly, so I apologize for that too. And then a lot of the things that we do, as folks know, if you've ever worked in, again, like e-commerce or really any industry, a lot of the ad platforms are actually similar across the industry. It doesn't really matter because everybody spends on Facebook, everybody spends on Google, right? Those are very common areas to get data from, and the structure of the data is generally the same, right? Maybe the currency is different or something, but typically it's pretty similar. So we wanted to be able to leverage, the code from client to client when it's like, okay, this person's on Shopify, they're in Google Analytics, and they're using, I don't know, say LinkedIn ads or something. We want to be able to replicate that client to another client that may be similar, just in terms of the data pre-processing, right? The models are different. And then we want to be able to use that information and make inferences with it. And if we don't have that all in one spot, that makes it really difficult for us. And then there's obviously all the best practices and stuff that come with building a system to manage all that. That again, we have a small, lightweight team. We just don't have the headcount to be able to manage all those things. Nor, I'm sure, if we tried to do it, we would do it particularly well. It's really not our area of expertise. So,
awesome. Yeah, makes a ton of sense, and definitely, even though maybe your business model is a bit specialized, I'm sure a lot of the people that have been building, models across like homogeneous data sources, right, that are supposed to be similar but have these like little nuances that make them different, have probably experienced some of the same challenges there. So this kind of describes like the challenges you're facing or anticipating, and then the solution you're looking to deliver. I think you kind of covered this nicely. So yeah, the ultimate goal is, I guess, from a Prescient perspective, to enable that onboarding to be, I guess, nearly automated. Is that accurate?
Yeah, and I think that actually, it's one thing I didn't touch on was really the for the management folks in the house. You probably don't really want your expensive headcounts doing a whole bunch of data pre-processing. Their brains can, probably do something much more useful. I'm not saying that data pre-processing isn't useful, but you probably get what I'm saying. It's not the most fun task. So that's one thing that we also didn't want to deal with, is we hired data scientists, right? So, of course, that we know how to write SQL and write our own ETL pipelines, but we're more on the research side of things, right? We're building new algorithms. The more time that we spend pre-processing data, the less time that we can spend doing the things that differentiate us as an organization. And so that's another thing that I should probably touch on that I didn't. But yeah, there's a time value of money associated with all of this stuff as well.
Absolutely. Good. So this was the point at which Rasgo got connected to Prescient, and I met Cody, which is awesome. We're both, fun fact, in North Carolina, by the way, which we found out much later after meeting. A couple of COVID moves in there. But yeah, so from a Rasgo standpoint, our feature store that we've been building now for about a year and a half it was a perfect fit for Prescient because a couple of reasons. So these were kind of the key tenets that we built Rasgo around. So ability to centralize your features, to automate these feature pipelines into models, and to enable a visual interface as a complement to the SDK, that it enables a lot of like self-service discovery and auditing. That's super helpful when, if you deployed a bunch of feature generation kind of automation like Prescient has, you want a quick way to go kind of confirm that that's working as expected, make any changes that you need, and curate those pipelines to make sure they're delivering the right data. So after a POC, Rasgo kind of got adopted by Prescient as part of that full pipeline. And after deployment, this is a really nice view of kind of what that final architecture looks like for Prescient. And this is kind of that foundation, I guess, that allows Prescient to start growing that customer base significantly, right, and taking on some of that scale. So Cody, do you want to hit the kind of non-Rasgo parts first, and then we can talk about how Rasgo fit in with kind of the decisions that were already sort of predetermined?
Yeah, of course. I can talk about ingest first because I think particularly interesting. So when we first started, Prescient's an interesting organization where we actually we spawned out of me and my wonderful co-founder ended up building a whole entire machine learning algorithm, particularly used to identify trends in the music industry. particularly what all of their spend was doing for particular artists, for a very, very large label, one of the 3 largest in the world. And they were having issues because they were losing any form of essentially causality between their marketing spend and the streaming volumes that they were doing. This is COVID, obviously, touring was put on hold, and that's kind of where all of our technology had spawned from. So we were able to prove ourselves through this industry. And one of the first things that we knew was, okay, well, if we're going to scale this across this industry, we're going to have to ingest tremendous amounts of data, right? 5 million different tracks and songs across all these platforms, and all this data coming in from all of these different areas where this particular label was spending, or multiple labels were spending their money, right? So automatically, we had this really difficult problem. We're going to have to pull in massive amounts of data from all these different platforms. So the first thing that we looked to do was kind of standardize this process of ingesting this data. We chose Fivetran for a partner in order to do this, right? Because again, we're researchers. We'd rather spend our time nerding out on math as opposed to nerding out on ETL. Personal preference for me. And so we use Fivetran again as more of a partner to do that for us, right? We're very buy not build heavy, I would say. We focus on where we're good. And so we have all this data coming in from all these different partners. And now we focused on, our first client in the e-commerce space had, again, these platforms that you see here. So like things like Facebook, Google Ads, Salesforce, Google Analytics, and Shopify. Now, at the time where we started to talk to Rasgo, in order to onboard a client, it actually took us a pretty good amount of time, right? Because we'd have to individually go in, talk to them, connect all these different pipelines, and then go and inspect all the different data that we have from all these different sources. And then if we wanted to bring on a new client, it would be rinse and repeat, right? Again, you'd have to go connect all the data sources, go in, check all the data, build the transformations for the data, pass that on to the model, and so on. And so we saw this after like 1 or 2 tries. We're like, yeah, this isn't going to work, right? We need to be able to scale this better. And again, as Patrick said, that's when we all started talking together. But once we get all that data, it sits in our Snowflake data warehouse. And again, that's because we've actually leveraged Patrick, and Patrick's much smarter than I am. We leverage him and all his subject matter expertise in order to help us identify some good architecture choices up front. And I'm lucky, I'm not coming into legacy infrastructure. I've actually been able to build most of the stuff from scratch. And then we have all this data in Snowflake. And since it's there, we can actually, basically, this image does a good job of it. We sit Rasgo right on top of that. And we leverage their SDK. And so what we can do with that is we actually are able to do a lot of our data transformations and data cleaning and all of that wonderful stuff in order to get the models to have the data that they need. And again, our models are very sensitive. As anybody here who's a machine learning practitioner of any sort, obviously, that data is pretty much the most important thing. And even, common occurrences like Pinterest, for example, their unit for dollars for spend is in microdollars, for example, right? And so obviously that would cause a huge issue with our models if we're scaling things, like min-max scaling all spends. If we were doing that, then Pinterest would always be high. And so we needed to see these types of things and then be able to come up with some scheme and then generalize that across every single client that we brought on board. And so Rasgo sits kind of inside of our whole entire machine learning pipelines, right? Now, it also lets us kind of keep our data separate from our modeling, which is very important to me personally. Again, I think like if you want me to nitpick at people, like Facebook's Profit API, for example, stores data within the model itself, which is like, that's not, why are you storing data? They're separate things. Odd choice. And so we're able to actually, because of Rasgo, keep these things separate, handle our data processing in one area, be able to look at, like have a GUI, be able to see what's going on, be able to inspect those features, being able to look at skew, like, obviously any form of statistical moment, right? We can look at all of them and see how the data actually looks. And then obviously it's on the analyst side to say like, okay, something looks wrong here or something doesn't look wrong here, right? But again, that's all done within Rasgo. So it's kind of like a one-stop shop for us to be able to inspect data, make sure the models look clean. And then obviously we have our own logging and stuff like that on top of our modeling, but Rasgo lets us get to that stage. And from there, we use Pachyderm, which is a great platform as well. We're able to actually schedule all of our Rasgo jobs within Pachyderm. We leverage the SDK within Pachyderm to be able to then train our models. And then from there, we use PyMC, which, like, if anybody has put Bayesian models into production, bless your heart. It's lots of fun. We use PyMC and we train our models that way. And so we have a whole bunch of cool stuff that come out of our models in terms of, we keep track of all the traces, we version all of our data, we version all of our traces, all of our predictions. We then do some forms of Constrained optimization as well on top of that, which if folks have ever used constrained optimization within production, is kind of has its own issues for various reasons. And we're able to actually store all of this stuff. But it all starts really with this ingest and then using Rasgo to help us transform this data. And then obviously that's in our pipelines for training. And then we actually are able to put our outputs wherever the heck we want them. We put them in several different locations, and I won't bore you with that because you probably don't care. Sorry for being so verbose, but that's in a nutshell.
No, that's awesome. This is my favorite slide. I'd rather spend all the time here. I thought it was a great description. So a little bit about Rasgo and like why we kind of made that choice on our side to when we started building the feature store to kind of bet heavily on the cloud data warehouse. So the modern data stacks kind of as it's growing and getting more popular, there's a lot of alignment around a single source of truth, right? And with Rasgo, we wanted to kind of ride that wave and like we believe in the future of that architecture because that single source of truth we believe should extend beyond just like data engineering and data for BI and really encompass like the data science and the machine learning use cases as well. And I think Cody hit nicely on a lot of the benefits there of like Rasgo is this metadata layer that helps me use my warehouse and the contents of my warehouse as features using the SDK. But it's not going to create a second, duplicative source of truth that I then have to manage the sync between the primary and the secondary. That's something that a lot of our customers have dealt with in the past, and that's part of why they're now using Rasgo is to avoid that problem. In addition, I think the key things you said around we talk a lot about features for training and then features for inference. I think it's really interesting what Cody's calling out around these artifacts of the models are in some ways, feature-like objects as well, right? And I mean that mostly from like a monitoring and a context standpoint is like you really want kind of a single place you can go where you can view, okay, what are the content, what is my model outputting? What's the prediction it's making? How can I measure the drift of that prediction similar to how I'd measure the drift of like any input feature, right? And so I think having a kind of central place to do that is we've heard that value from multiple customers. And then another thing you said that was cool is like Pachyderm as this kind of infinitely scalable, like theoretically training layer. But all it has to do from a data standpoint is reference the right feature or collection ID is what we call it. But it's like a grouping of features, right? Like a joined denormalized grouping of features for model training. So within Pachyderm, it's just making that call to the Rasgo API, retrieving the specific kind of SQL query that it needs to process from Snowflake and ingest. And then that becomes sort of the modeling data set. And then similar paradigm for inference. So yeah, really nice, I think, symbiotic relationship there, I guess, both on the Fivetran side and then on the Pachyderm side.
Yeah, definitely. And I think it's actually kind of cool what you called out in terms of our models, like I said, or have said probably to everybody else is blue in the face, are hierarchical, right? So these things are large graphs internally that, we have multiple different machine learning models that are part of this like directed acyclic graph where we actually need to reference, obviously, things in the graph along the way. And so we treat, like, for example, marketing as an independent variable, right? And it's an independent variable that could impact a dependent variable. There's other things that could impact that dependent variable as well, right? We need to keep track of those things. And Rasgo lets us do that, lets us reference those things because we able to reference them. But then again, for our own internal purposes, if I want to keep track of how the accuracy is working, well, again, it's relatively easy, and Rasgo kind of is a one-stop shop for me to understand how all of my clients are functioning, not just how a singular client is functioning. So it's kind of a cool way to get like a window into that as well.
That's awesome. Yeah, control center for ML. That's what our customers have asked for, and to kind of expand on that, like the kind of key product capabilities that Rasgo focuses on are really three pillars. So understand, prepare, and serve. The one that might be a little bit different from some of the other feature stores is the prepare, so the central one. But first, let me talk about, so understand that's all about being able to go to Rasgo to quickly get context on like pre-existing features, right? So I myself or my colleague has built features yesterday. I need context on those features, right? I need, contextual things about how are, what's the drift on those? Like, how are those performing? Are they being served to production models right now? How are, what's the upstream ingest of that data? Like, what does that entail? Where are these coming from? So that's where a lot of our UI usage is really, I would say, focused in that understand bucket. Like it's a matter of gathering that context about what you've published to Rasgo. Prepares is different. That's more of an SDK experience. We find like we try to keep feature parity on our product between our SDK and our UI, but like obviously certain activities just lend themselves better to like certain sort of interfaces, right? So on the prepare, that's where we allow our users to apply transformations to data. And the SDK is absolutely kind of where people are most comfortable, right? Because they're used to working in pandas and PySpark there and kind of doing some of that pre-processing. So we've looked at ways to bring that back into your data warehouse, again, emphasizing that single source of truth. So you get the scalability and the centralization of that, which means from a user standpoint, I want to be able to write Python in a pandas-like experience that I'm used to, but I want that to compile and execute as SQL so that I'm getting the feature transformations, are parallelized. They're infinitely scalable theoretically with like a Snowflake virtual warehouse construct. And then finally, serving, like super important, right? That's kind of where you have to start, but you have to be able to serve both that training data and then the lookup vectors for inference. And we do that with our SDK, and it's really like one line of code that does the heavy lifting there. So typically extract to a data frame, parse that into JSON, do a lookup if you need, and then make your prediction and store that back in S3 or Snowflake. This is a bit more detail on the transformers. Cody and Cody's team have been awesome kind of being early design partners for some of this functionality from the Rasgo side. And this is something that this is like our concepts that allow that Python first experience, but the execution to come in SQL. So we call that user-defined transforms. And that's a big bet that we're making, that data scientists are best and fastest writing Python and kind of applying these Pythonic-like arguments to transformations, but that they really will benefit from that executing within a SQL paradigm. I want to make sure we have time for questions. So let's, I've hit on this one kind of extensively, but like the final slide here is Rasgo's an abstraction layer. So we believe that we don't need to be a separate data warehouse for your features. You already have a data warehouse. Let's use the power of that to deliver your features to your models so that your physical data stays in Snowflake, but Rasgo can help version, manage, and abstract the feature definitions as a metadata layer on top of Snowflake. Awesome. So let's open it up if there's any questions, and we can hit a couple in